my best friend, and I'm glad to hear your voice.
All right, welcome to a new episode of the Roscoe's Wetsuit Neuro podcast. I am your host, Toby Passman. Roscoe's Wetsuit Neuro offers premium brain health coaching to clients globally, along with targeted neuromodulation services to clients interested in peak cognitive performance in the Miami-Fort Lauderdale area. Go ahead and check out roscoeswetsuitneuro.com for the latest. Sign up for our free email newsletter, along with booking a free 15-minute coaching call to see if brain health coaching is for you. Brain health coaching will encompass talking about diet, supplements, nootropics, sleep, and other aspects in which you can increase your cognition. So if you're interested, go ahead and book that free coaching call at roscoeswetsuitneuro.com today. If you have any comments, questions, or requests for the show, go ahead and DM us, Roscoe's Wetsuit Neuro, on Instagram, or email us, roscoeswetsuitpodcast@gmail.com. I'd love to hear from you guys. On to the show today, we have a very special guest, Dr. Ginger Campbell. Dr. Campbell is an experienced physician with a long-standing interest in mind-body medicine, the brain, and consciousness. She's interested in a wide variety of other topics, including the history of science and ideas. She began podcasting in 2006 and has discovered that it's a great way to share ideas with people from around the world. And her specific podcast is called the Brain Science Podcast, in which the goal is to explore how recent scientific discoveries are unraveling age-old mysteries such as intelligence, emotions, personality, and memory. So Ginger, really excited to have you on the show today. Welcome.
Thanks for having me.
I read in your bio that you started podcasting in 2006, and I was curious as far as that seems like a relatively early days of podcasting. I was just wondering kind of how you got into that world, and how brain science eventually, how that actually became a show.
Okay, well, I discovered podcasting in 2005. It officially began in 2004, but I discovered it in 2005 when it appeared in iTunes for the first time. And the first time I heard a podcast, I was just like, oh, this is so cool. I want to do it. But I didn't know, what I would do a show on. And it took me about a year. And what happened was I did a book review for someone else's podcast. And it was about a book by Jeff Hawkins called On Intelligence. And after I recorded, it was a very short episode, about 10 minutes long, I was like, this is it. I could do neuroscience and I would never run out of material. And it was interesting because at the time, the reason I picked it was because it was the thing that I was interested in. I'm not a neuroscientist. It was just the thing I was reading all the time. And it wasn't as popular or as hot as it is now, but it certainly has stood the test of time, so to speak. I still never run out of material.
So tell me about you. You mentioned how you're not a neuroscientist. So was that sort of a difficult thing to start talking with all of these neuroscientists and being able to sort of know what to ask them, how to kind of steer the conversations without actually being a neuroscientist yourself?
Well, I have a background in engineering and medicine. So with that background, I was able to, read the books that I chose early on were not as technical as the ones I use now, but actually not being a neuroscientist is an advantage. I know enough to ask smart questions, but I also know how to put myself in the place of the non-neuroscientist, which is what neuroscientists need. If they're going to communicate their ideas to the rest of us, sometimes they need a little, help. And I think that's really where my show comes in, is that I try to ask questions that will help the neuroscientists to bring their passion to other people. And that's really the key to the show, is making it accessible to people of all different backgrounds. And it's really about asking questions that bring out the key ideas so the scientists don't get lost, in the details. because when you're a working scientist, your bread and butter is all those details. But when you're sharing your work with somebody else, you got to be able to tell them what the big picture is. Why is this thing you're studying important? And that's not always easy to communicate.
Right, right. It's that sort of translational neuroscience, and sort of the way I see it and describe it as sort of bridging that gap between the hardcore researchers and clinicians and the lay people who might have an interest in this stuff, but maybe aren't going to be able to read a full research paper and understand every single term that's being discussed there.
And one of the things I do is I focus mostly on interviewing scientists who've written books, and their book might not necessarily be aimed at a general audience, although I vary between books that are aimed at general audiences and more technical books. I have a very diverse audience. And so one of my challenges is making the show appropriate for such a diverse audience. I do that by alternating the technical level, the content from month to month, to keep everybody sort of happy. And so when I pick the books, that's really, first of all, it simplifies my research. I do read some of the basic papers, but I'm really interested in the people who put the information together into book form. That tells me that they have a certain communication skill, right? Which is going to come in handy when I interview them. Because let's face it, not all scientists make great interviews.
Yes.
So that's kind of my screening is, can you write a book? If you can write a book, then you can probably do an interview. And that usually works.
Interesting. So tell me about like some of the favorite episodes that you've had so far.
In thinking about your audience, because this is a show about making the information practically available to people, my favorite all-time episode, unfortunately, has horrible sound quality, but it was an episode where I interviewed Dr. John Rady about the value of exercise in the brain. And this episode was originally aired, let's see, in 2008. And so now everybody knows, oh, exercise is good for your brain, but it was really kind of a new idea at the time when he first wrote his book, which was called Spark. John Rady, the book's name is Spark. And that was really great because it's something you can use. I mean, knowing that exercise is good for your brain, can motivate those sort of scholarly types who might not necessarily enjoy exercise, but they care about their brain. So that's one of my favorites. And then another favorite guest is a guy named Seth Grant, who is one of the few guests I've had that has never written a book, although he probably could write a great book. He's discovered all kinds of fascinating things about the synapse, which is the space between neurons where all the interesting stuff happens, where one neuron communicates with another. And he's made some very fascinating discoveries. And he's so good at explaining things that it doesn't matter that he's never written a book. I mean, he's just the greatest explainer. So he's been on maybe 5 times over the years because I've watched him make, a series of fascinating discoveries. I really think he'll get a Nobel Prize eventually. So remember, someday when he gets a Nobel Prize, remember that I told you. So those are two of my favorites. And then I've had over the years a lot of different people come on talk about consciousness, and almost all the key players in the field, and so that's a theme that people are naturally interested in. So I think that's one that you can come in at any level and appreciate.
Right, right. I was actually just listening to one of your episodes recorded with a gentleman I believe you actually referenced a few minutes ago, Jeff Hawkins, the newer one that you put out with him, where you were talking about how that's the majority of the guests that you have on are, their kind of main question is addressing consciousness, whereas Dr. Hawkins, I guess, his question is kind of measuring intelligence, or how the cortex generates intelligence, right?
Right. He made a very important point, both in his new book which is called 1,000 Brains, and in the interview, which is that intelligence and consciousness are not the same thing. And so if we wanted to make, because there's a lot of debate about whether or not we could make a artificial intelligence that is conscious. And I think he makes the important point that they aren't the same thing. And whether we would ever actually want our artificial intelligence to be conscious is something that at some point we really probably need to have some ethical conversations about, right? Because if we actually made something conscious, then that would imply certain ethical obligations on our part. So one might even argue for, let's make the machines intelligent, but not conscious.
That's a very interesting distinction. So based on kind of you having talked to all of these different neuroscientists a lot about consciousness, where do you sort of stand on the issue now, as far as there being so many different theories of consciousness and what it is and what it's not, based on kind of all of those
I mean, right. I'm not wed to any particular theory. I am committed to the basic principle that consciousness requires a brain, and also that our brains are embodied. That is, our brains are part of a body, and that subjective experience, which that's what consciousness means. Consciousness means that you have some awareness and a subjective experience. So in order to have subjective experience, you just about need to have a body. I don't believe in the brain in the vat would be a person, right? That gets back to the whole, well, how would we make artificial consciousness if we could? There's a whole field called embodied cognition that argues that the way we experience the world is totally dependent on the kind of body that our brain is in. So there's a famous philosophical paper from the 70s called, what is it like to be a bat? You may have heard of it. But it captures the idea that the subjective experience of being a bat would be entirely different from the subjective experience of being a person. Even when we are talking to other people, we know that our experience is different from theirs. I'm in my body, you're in your body. So I think embodiment is important. And when it comes to consciousness, we're totally dependent on our brain, right? The brain gets its information from the sensors that, send it information, and then it generates what we experience. So, I guess you could argue, well, maybe we are like in the Matrix or something, we would not know, but I'm not really very interested in that particular idea. It's just, to me, not really interesting. But I do think that each one of us is in a certain body. Our experience is totally created by our brain. And my biggest commitment really is that I don't think that the mind is something non-physical, which would make me not a dualist. Before I started doing brain science, I was interested in Buddhism, which kind of has this idea that the mind is somehow separate from the brain. But that was because there were certain things I thought you could only, that the brain couldn't do. But we've learned that that's not true. For example, you can create an out-of-body experience by stimulating certain places in the brain. So my biggest theoretical commitment would be to say that our consciousness is totally dependent on our brains. And beyond that, a lot of it is debate. I guess that I lean away from the integrated information theory that is kind of a panpsychic view. I'm not really too enamored of that, despite my respect for Christoph Koch. Other than that, I'm not particularly tied to a particular theory. I think that a lot of the theories, they have their bits and pieces that make sense.
Have there been any big surprises or big, I guess, big ideas that have changed the way that you think about the brain or our experience of reality, just kind of that may have kind of contradicted, like, I guess, anything besides the sort of dualism idea? Anything else that has stood out that a guest may have shared on your podcast that really was like, wow, I didn't realize that about the brain, or how the brain creates our subjective reality?
Well, I guess the biggest thing is just coming to appreciate how much of what our brain does is unconscious. That is to say, to say that it's not accessible to our consciousness. Most of what our brain does is in a certain sense automated. And for example, perception, we don't have conscious control over our perception. That's the reason why, if you look at a visual illusion, even though it's an illusion, it doesn't go away, right? Because you can't control the part of your brain that's processing the vision. So that is, it's very humbling. And the other thing that we've learned more and more about, and I'm going to be having David Eagleman on probably next month to talk about this, is how the brain is constantly changing. That you can send audio information to the visual cortex, say in a blind person, and it starts processing that information. In fact, if you blindfold somebody to teach them how to appreciate what it's like to be blind, and you start teaching them Braille, immediately it starts showing up in the visual cortex. I mean, in less than an hour, which means that there are already connections there, right? It's not new connections, it's connections that are already there. So that's pretty wild. So people are creating prosthetics, visual prosthetics that basically are going to be sending visual information from, say, a prosthetic from a camera to the skin, or all these different wild things you can do, because it turns out that cortex is cortex is cortex. And this kind of gets back to Jeff Hawkins' approach to how the cortex works. So it's one of those ongoing debates that neuroscientists have had about, localization versus networking versus it's who you talk to versus where you talk. These debates go on and on. But it's becoming, as you in your field probably know, it's becoming more and more practical to actually use this stuff to do things that help people.
Yeah, so I kind of wanted to hear your take on sort of like applied neuroscience in terms of the different technologies of neurofeedback and neurostimulation.
Okay.
And also, I guess, kind of along with your opinion, just kind of what you've heard from a lot of the neuroscientists you've interviewed, because I was pointing out I feel like oftentimes a division between the people who do that, like, kind of applied neuroscience work, often being kind of licensed psychologists, clinicians, compared to the crowd of kind of hardcore neuroscientists who often seem to reject those sort of technologies. I just wanted to kind of hear your take on that.
Yeah. So I think that neurofeedback has a lot of potential. I think the reason why neuroscientists tend to be skeptical of it is that our level of understanding of how it works at this point is so poor. And the clinicians that are doing it at this point are kind of, they're doing what works. Okay. And, I can't keep up with all of their writings, so I'm sure that some of them have some ideas about why they think what they do works. But nobody's come up with anything that has really, made it into the neuroscientific mainstream, you might say. And for me, for the show that I'm doing, my goal is kind of to get the basics across and to get across this is how science works. And so I think that neurofeedback is one of those things it's at some point going to be mainstream, but the problem is that clinicians need to take care of patients. They don't have time to worry about, doing the kinds of experiments that would be required to get into the neuroscientific mainstream. So it's kind of like there's a gap there that I'm not sure how that gap is going to be filled. I'm sure that it will be filled at some point. But like I'm often asked to do that, to cover neurofeedback on my show. And the reason I don't is because I don't think I can do it justice. I've read a few books about it, but there hasn't been anything that was solid enough that I could say, hey, I'm ready to share it, right? So I'm for neurofeedback. I think there's reason for hope. I just don't think that I understand where the scientists are coming from, and I understand where the clinicians are coming from. The clinicians want to help people, and the scientists want to have good science. And right now they're not really talking to each other.
Agreed.
And I don't feel like it's my job to solve that problem. There's enough other great neuroscience for me to share with my audience. So that's I'm just one person doing a monthly show. And whenever somebody comes to me and says, I want you to do this clinical thing that we're doing, that's great, and I want to tell you about it, I say, that's great, but that's not what my show's about.
Right on. Ginger, I wanted to switch gears a little bit and sort of talk about the process of growing your show into what it is today, which I saw it's a #1 ranked show on iTunes with and you just passed 10 million downloads. Tell me about kind of not being a neuroscientist yourself, how you were able to start getting all of these guests on your show and growing a neuroscience show. I just wanted to kind of hear about that process.
Yeah. So I'll tell you how the show started. At the beginning, I wasn't doing books written by scientists. Okay. Jeff Hawkins is kind of a special case, but I did a lot of basic books at the beginning, and my first interview was almost by chance. And then I realized, hey, interviewing is pretty good, and I enjoyed it, and I started doing that. And as I started the first 2 years, I did the show twice a month, and I would do maybe a discussion and then have the person come on and we'd sort of fill in the gaps, right? Then I went to a monthly show, and at that point, I sort of shifted to more of a focus on interviews. By then, I was starting to do more technical content, because if you looked at my content, I usually tell listeners who write to me, you could use the first 2 shows, first 2 years, which is about 52 episodes. You could use those as your neuroscience primer, you might say. So the show has evolved by what I'm interested in, also the fact that I get feedback from my listeners. That feedback is really important if you're doing a podcast. You've got to know who your listeners are. I imagined a certain sort of like NPR kind of person, but that's not actually who listens to the show. The show is actually the listeners are more diverse. I've had high school students, house painters, tattoo artists. People that may not even had a chance to study any science, all the way up to MDs and PhDs. So that's its own, like I said, challenge, which I deal with by varying the level of the content. The key idea there is that if I'm talking to somebody and I know that some of my listeners are going to know less than other listeners, I have to make sure that our guest defines the key terms. People don't have to know every little thing, as long as the 2 things is listeners do not want to be talked down to, right? And they got to be able to know what the big picture is. As far as getting guests goes, most scientists are very generous with their time. Most scientists are extremely passionate about their work. And most of the people that I interview are not like celebrities. They might be, well known in science, but they're not, they're not even, Neil deGrasse Tyson, right? They're not science celebrities. So with the exception of a few that will only do interviews when they're in little time pockets, like I will finally get Antonio Damasio on the show because he has a new book coming out. And his publicist already set it up, already sent me the thing, and we're going to do it. So it's going to come out right in the window of that book coming out. But, most of the guys are not making any money off the books they make, right? And they're just happy to share the only person I ever had that said no was Oliver Sacks. But I mean, he was in really bad health, and, it wasn't a big deal. But timing is, if you really want to interview somebody and you're having problems, the key to it is to realize that their most likely time to be interviewed is right when their new book comes out, right? If you're having an issue. And then, of course, once you've interviewed a number of people, then you've got, you street cred, so to speak. I don't really have any problem because my show is really the show every neuroscientist wants to be on, to be honest. It didn't start out that way. But you do a few interviews with people and they enjoy the fact that they're not turned into sound bites. They enjoy the fact that they get to express their ideas thoroughly. It kind of takes on a life of its own.
What have you found as kind of the best ways to sort of, like you mentioned, sort of the importance of knowing your audience and being able to actually like know what they want? Have you like spoken to people individually, or do you ask people to like email you? Like how do you find is the best way to actually like connect with your listeners?
Well, my favorite thing is email. I guess that's probably a generational thing. I think other people might prefer social media, whereas like I'm horrible about never even looking at the Brain Science Facebook page. I know people post things there and I probably never see them, and I apologize. But if somebody emails me, I always respond. And I tell my email every episode, and that's my key tool.
Awesome. If are there any specific people as far as that you're really wanting to interview going forward, or anything, any as far as like the direction of the show moving forward? Is there anything that you're wanting to do with it?
Make more money. Yeah. I'd like to grow the show. I'd like to reach more listeners. Obviously, we always want more listeners, right? As far as guests, I don't have any particular aspirations. I've learned over the years that I actually don't care so much about getting famous guests on my show. They don't need to be on the show. I would rather interview somebody who no one's ever heard of, who wrote a great book that no one's ever heard of, and get their ideas out there. Antonio Damasio doesn't need to be on my show. And actually, I don't need him either, but my listeners want him to be on the show. So that's one of those things, he's one of those guests that people have asked for years. And he almost got on there a few years ago, but we just never could get our schedules gelled. I think my dream guest is Billie Jean King, and she doesn't have anything to do with neuroscience.
Got it. As far as when we're talking about just kind of like neuroscience in general moving forward, with kind of what you've heard from all your guests, what are some of the most like exciting ideas or aspects of neuroscience that you feel like are going to really play a big role in kind of advancing the field as we go forward?
Well, I mean, we really have made huge strides in understanding how the brain creates consciousness. I mean, I will be having Anil Seth on soon, and he's of the next generation that's actually spent his whole career doing the neuroscience of consciousness. I started out talking to people of the generation of Christoph Koch and Patricia Churchland, when people were almost driven into philosophy because it was concerned consciousness was a no-no. It was considered scientifically unstudyable. So that's been a big change, and I think that's going to continue. The progress in doing brain-machine interfaces is amazing, and I think we're probably going to be seeing some really amazing things with that in the future. We're going to go from prosthetics to expanding what a normal person can do with these interfaces. But we're also going to be facing, ethical decisions about things like, do we want to try to create consciousness? The most important, a thing that I think is important that people understand is that we are a long way away from uploading our consciousness into a computer, okay? Because there is a subset of people in the field who argue that it's within going to be soon. And I just don't think that's true, because there's still large gaps between what we do understand and what we would actually need to understand to do that. And I think it's important, because if you're thinking that, hey, I don't care about global warming, I'm going to upload my consciousness to a computer. Nope, that's not the solution. You need to care about global warming.
What are some of the kind of basic premises of neuroscience that you feel like are really important for kind of the average lay person who's not in the field but who's very interested in neuroscience, for them to understand? Maybe some things that you've learned just talking to as many neuroscientists as you have. I mean, I feel like you just kind of touched on one, as far as the misconception that we're going to just be able to upload our consciousness to the cloud, at this time. But what are some of the other kind of foundational ideas of neuroscience that you feel like are really important for people to understand?
Well, one is kind of a subset of the fact that the brain creates the experience that we have of the world. And a practical outgrowth of that is that some things do not work the way people imagine. So, for example, probably the most flagrant one is memory. Okay, memory does not work like a video camera. You do not store like this exact recording of everything that happens. Instead, what happens is every time you remember something, you recreate the experience in your brain, and it changes. So memories are dynamic, and they're constantly being distorted, you might say, by things we learn or happen to us in between. Do you have brothers and sisters?
I do not.
So those of us who have siblings know that if you ever talk about your childhood, you'll discover that you remember things they don't remember, and they remember things different from what you remember. And you could get into a big fight about it. But the reality is that our memories are just, they're highly unreliable. And there's actually a new theory out there that says that the reason that they're unreliable is that their purpose is not what people imagine. That the whole purpose of memory is, have you heard about the predictive theory of the brain?
A little bit, I believe.
Okay, so it's basically the idea that the brain is about prediction. It's constantly trying to predict what's going to happen next, and that the purpose of memory is for us to predict what's going to happen next. And so for that purpose, it doesn't need to be exact. It doesn't need to be the kind of way that we imagine it to be. It just needs to be good enough. And so this has a lot of practical implications. I mean, people get attacked because they change the way they told a story. Well, that's the way people tell stories. They change. It doesn't mean that person lied. Okay. It doesn't mean that the person has dementia because they've changed the story. That's it actually means that eyewitness testimony, unfortunately, is very unreliable. And if we took how it really works, what we would do is when something happens, the police would record the very first thing someone said about it, and then they would never ask them again, because it's not going to do anything but get less accurate over time after they talk to other people. So that's an example of why neuroscience is practically important.
Right, right. Going off of that, I remember there was in one of my psychology classes in college and undergrad, we talked about the kind of the with memory, kind of that every time you recall a memory, there's reconsolidation that's occurring, so that really every time you think of the memory, you're changing it, a bit, and then your next recollection of that memory is what you're really you think you're recalling that original memory, but what you're really recalling is how you last recalled that memory.
Right. Or this recalling of the memory, which
Yeah.
will feel like it's right. And it's also been shown that the idea of the flashbulb memory being more accurate, not true. It may feel more emotional, and you may be absolutely sure that your memory is correct, but that feeling that you're right is not reliable. So, if people understood that, I think that they would perhaps take a step toward being more tolerant toward one another in a lot of different dimensions. Same way with when I was talking about the role of the unconscious processes. When you feel certain about something, that's also generated by unconscious circuitry, right? So two people can look at the same facts and draw different conclusions. And that's just reality. And you don't choose what you believe. I mean, that happens. I hesitate to use the word unconsciously because it brings out, ideas of pseudoscience like Freud, but it does happen outside of conscious awareness. And that being the case, I think I'm right, you think you're right, and there's no humility there because and if people really understood how our brains really worked, I wish that we could, like I said, have more tolerance. If there's anything we need in the world right now, that's something we need.
Well said. I mean, I think that definitely would occur if we were able to understand how if everyone kind of had a basic understanding of neuroscience and psychology, and understood that what's right to me is not necessarily right to you. And that's a lot based on our own, unique neurochemistry, neurobiology, along with just our past experiences all being different from one another. In sort of wrapping up today's discussion, any kind of closing thoughts related to anything we've discussed so far? Any kind of take-home messages for people listening?
Okay, well, my show is called Brain Science, and the tagline is the show for everyone who has a brain. And that is really my goal, is to make neuroscience accessible to people of all different backgrounds. You don't have to, have a science degree. If you have a science degree, that's great, but you don't need one. I really think that we need a better basic understanding of neuroscience so that we don't get scammed, if nothing else. I mean, there's an awful lot of neuro hype out there right now. There's a lot of people trying to make their fortune off of the popularity of neuroscience, and the fact that people know about neuroplasticity, and they can just sell them just about any little thing that claims that it's going to be good for their brain. So I would encourage people to do your own homework, and that's kind of what I try to do. I do some of the homework for you. And if you want to listen, you can check it out at brainsciencepodcast.com or in wherever you listen to podcasts.
Awesome. Awesome. And if you guys enjoyed the show today, please like and subscribe to our YouTube channel, where Roscoe's Wetsuit Neuro. Also, go ahead and subscribe on whatever audio platform that you listen to the show on. Thank you so much for your time today, Ginger, and sharing all of your expertise. And I look forward to continuing to listen to brain science and hearing all of the amazing guests that you continue to interview.
Well, thanks for having me.